Building and maintaining roads combines precision, innovation, and durable technologies, ensuring safe, efficient travel while shaping the backbone of modern infrastructure. Simbeton is a professional company specialized in the installation of high-quality precast concrete slabs throughout the Netherlands and Belgium. Their work emphasizes precision, durability, and a perfectly level surface. To achieve this, Simbeton employs advanced techniques and specialized equipment, such as truck-mounted cranes equipped with vacuum lifting systems. These machines ensure that each concrete plate is positioned with millimeter accuracy, guaranteeing a stable and long-lasting pavement. The first and most crucial step in the installation process is preparing the subbase. A solid and level foundation is essential for the stability and lifespan of the concrete pavement. The foundation typically consists of a sand layer at least 25 centimeters thick. This sand layer is evenly distributed, compacted, and leveled using laser-guided equipment to ensure an even surface. To guarantee proper drainage, the surface is prepared with a slight slope, at least 0.5%. This inclination allows rainwater to flow away easily, preventing water accumulation under or between the slabs, which could cause uneven settling or frost damage during cold seasons. Once compacted, the base layer is carefully inspected to ensure that no soft spots remain, as these could lead to differential settlement later on. After the base preparation, the precast concrete slabs are delivered to the site on heavy-duty trucks. Each slab is precast at Simbeton's factory under controlled conditions, ensuring uniform quality, strength, and surface smoothness. At the site, the slabs are unloaded directly onto the prepared base using a hydraulic crane equipped with a vacuum lifting system. The vacuum lifter is one of the most efficient and safe methods for handling large concrete elements. It uses suction power to lift and maneuver the heavy slabs without causing surface damage or requiring additional lifting hooks. The operator controls the system from the crane, positioning each slab precisely in its designated place. This mechanized installation minimizes manual labor and increases both safety and accuracy on the construction site. Each concrete slab is placed with extreme care. A spacing of approximately 5 millimeters is maintained between adjacent slabs to allow for thermal expansion and prevent edge chipping. To ensure uniform spacing, Simbeton uses 5 millimeters wooden spacers placed temporarily between the slabs. These spacers maintain consistent joint width and alignment throughout the installation. The slabs are aligned in both longitudinal and transverse directions to create a continuous, flat, and visually appealing surface. Precision in this step is crucial, especially for applications such as industrial yards, agricultural sites, or heavy traffic areas where uneven joints could affect vehicle movement or drainage. Once all the slabs are properly positioned and aligned, the joints between them are filled with fine sand. This process serves several purposes. First, it stabilizes the slabs by filling the small gaps that might otherwise allow movement under load. Second, it enhances the overall interlock between slabs, creating a tight and stable connection. Finally, the sand filling improves drainage and prevents vegetation from growing between the joints. The sand is spread evenly across the surface and brushed into the joints several times. Vibrations from traffic or compacting machines help the sand settle deeper into the joints, so additional sand is often added afterward to achieve full compaction. This repeated sanding ensures long-term stability and durability of the concrete surface. After the installation and joint filling are complete, the surface is thoroughly checked for alignment, levelness, and joint consistency. Any uneven slabs are adjusted by lifting and releveling them to ensure a perfectly flat finish. The completed surface is durable, easy to maintain, and immediately ready for use. Installing concrete slabs is a specialized task that requires experience and precision. Cymbiton's professional approach ensures that every step from ground preparation to final finishing meets high standards of quality. The use of vacuum lifting systems not only speeds up installation but also minimizes the risk of damage to the slabs, which can occur when using traditional lifting chains or hooks. The main advantages of Cymbiton's installation method include rapid installation with minimal manual handling, accurate alignment and joint spacing through the use of spacers and vacuum systems. Proper base compaction and sand-filled joints ensure long-term stability. Suitable for a variety of applications, including industrial pavements, agricultural yards, parking lots, and storage areas. Through this meticulous process, Cymbiton ensures that every concrete slab installation meets the highest expectations in terms of functionality, strength, and appearance. The combination of advanced technology, skilled operators, and strict quality control makes Cymbiton one of the leading specialists in concrete slab installation across the region. The paving crew from U.S. Pavement Services is working efficiently to resurface the road. The process begins with a milling machine removing the old asphalt to create a smooth, even base. Then, dump trucks deliver fresh, hot asphalt to the job site, which is poured into the paver. The bright orange paver spreads the new layer evenly over the surface, under the guidance of skilled workers. Workers carefully control the thickness and smoothness of the asphalt, ensuring even compaction. Loader helps handle the material and clean the area. Behind the paver, compactors and rollers follow to compact the asphalt, providing durability and a perfect finish. The crew, equipped with safety vests and helmets, work with precision and coordination. This coordination ensures a high-quality, long-lasting pavement suitable for both commercial and public use, demonstrating modern efficiency in road construction. The construction of Dollar General's new parking lot begins with preparing a strong and stable foundation. First, a thick base layer of gravel is carefully laid down across the entire area. This layer is then smoothed out and compacted to create an even, solid surface. This crucial step ensures that the new pavement will have the strength and durability needed to handle heavy traffic and long-term use. Once the gravel base is complete, trucks carrying hot asphalt begin to arrive at the site. The asphalt, specially mixed with 25 mm aggregate, is dumped into the hopper of the paving machine. The paver then spreads the asphalt evenly onto the prepared surface, laying it at a thickness of approximately 2.5 inches and a width of more than 14 feet. Immediately afterward, heavy-duty rollers compact the freshly laid asphalt. Each inch of asphalt must be compacted by about 1/4 of an inch to maximize the load-bearing capacity of the pavement. Meanwhile, skilled workers use lutes to spread and smooth the asphalt around edges, drains, and other obstacles. This detailed handwork ensures that the surface transitions smoothly and maintains a seamless finish throughout the lot. The same paving and compaction process continues until the entire area is evenly covered with the 25 mm mix. After completing this base asphalt layer, the crew repeats the process using a finer top mix asphalt. This upper layer contains smaller stones, which help achieve a smoother and more refined surface texture. Once the top layer is compacted and cooled, the parking lot is ready for its final step striping. Fresh white and yellow lines are painted to mark parking spaces and traffic flow. With that, Dollar General's new parking lot stands completed, smooth, durable, and ready to serve customers for years to come. Have you ever wondered how road builders create all those specially shaped curbs and gutters? In modern road construction, these elements are formed using precision curb machines. The process begins with preparing and leveling the roadside base. Then, a concrete mixture is poured into the curb machine, which shapes it into continuous curbs or gutters according to the required design. Skilled operators guide the machine to ensure straight, smooth, and durable edges. Once formed, the concrete is left to cure, creating strong borders that define the road structure and improve both drainage and safety for vehicles and pedestrians. The Stripehog water blasting system, SH8000, efficiently removes thick pavement markings from asphalt surfaces. Using high-pressure water, it eliminates old lines without damaging the pavement or creating ruts. After cleaning, the asphalt quickly blends with its surroundings, leaving no trace or conflicting markings, ensuring safety and a uniform road appearance. The slab lifting with polyurethane foam method offers a fast, clean, and cost-effective solution for repairing uneven driveways. Instead of replacing the slab or using heavy cement grout, this process employs AP Lift 430 polyurethane foam, requiring only small 3/8" drill holes. The lightweight foam is injected beneath the concrete, where it expands and gently lifts the slab back to its original level. This technique minimizes disruption and eliminates the mess associated with traditional mud jacking. Once lifting is complete, the holes are patched, and all cracks and joints are sealed with silicone to restore a smooth, durable surface. Crews ensure the site is thoroughly cleaned, and in most cases, the concrete is ready for use within 45 minutes after completion. This modern polyurethane foam method combines precision, speed, and reliability for long-lasting concrete repair. The chip and seal paving process, where crews apply this cost-effective road surfacing method with careful coordination and skill. The operation starts with preparing the roadway surface, ensuring it is clean, graded, and ready to receive the new layer. Once the surface is prepared, a distributor truck moves along the road, spraying down a hot layer of liquid asphalt emulsion. This spraying step is essential because the emulsion acts as the bonding agent that will hold the crushed stone firmly in place. The operator ensures that the spray bar is correctly adjusted so that the asphalt is distributed evenly from edge to edge. The process is done in several passes to make sure the coating is smooth and consistent over the entire length of the road. After the asphalt emulsion has been applied, the next step involves the use of the chip spreader. A dump truck loaded with crushed aggregate, typically 3/8" chips, backs up to the spreader and hooks onto it. Once connected, the truck slowly moves forward while the spreader opens its gates, allowing the stones to fall in a uniform layer over the freshly sprayed asphalt. The distribution rate must be carefully controlled to ensure the correct coverage without excessive loose material. The chips used in this project are angular and durable, providing excellent interlocking and a strong surface once compacted. Immediately after spreading the aggregate, rollers follow behind to embed the chips firmly into the asphalt binder. The rolling process requires multiple passes to guarantee proper seating of the stones and to minimize stone loss. Pneumatic tired rollers are often used for this stage because they provide flexible pressure that pushes the chips securely into the binder without crushing them. This compaction step is critical to achieving a durable and even surface texture. Depending on the condition of the existing roadway and the required durability, the process may include 2 or even 3 layers of chip and seal. Each additional coat involves repeating the same sequence of spraying, spreading, and rolling. Multiple layers enhance the road's strength and extend its service life, making it more resistant to weather and traffic wear. Once the final layer has been compacted, the road surface is left to cure for a short period. Any excess loose stone is later swept away, leaving behind a clean, textured finish. The result is a hard, skid-resistant surface that offers good traction in all weather conditions. Overall, the chip and seal process demonstrated in the video is an efficient and cost-effective alternative to hot mix asphalt paving. By combining liquid asphalt with crushed stone, the method produces a durable, weatherproof surface that can be quickly installed and open to traffic within hours, providing excellent performance and longevity for rural and secondary roads. The HBM grader, equipped with Stehr attachments, is a specialized system designed for the efficient and environmentally friendly maintenance of forest roads. Developed by Thuringen Forst and the Hessian company Stehr, this setup combines multiple road maintenance functions into a single, highly effective machine. The system includes a hydraulically operated ripper mounted on the middle blade of the grader and the Stehr plate compactor model SBV80H2G attached to the rear via a special suspension. The process begins with clearing the road shoulders so that the road surface material can be pushed back toward the driving path. Deep ruts and potholes, which often trap water, are eliminated as the ripper loosens the road surface down to the depth of the damage. This ensures thorough mixing of the existing material without adding new aggregate, saving both time and cost. Once the surface is loosened, the material is moved toward the center of the road to form a proper crown shape, allowing rainwater to drain off to the sides effectively. Next, the Stehr plate compactor performs the final compaction. Its specially designed suspension allows it to compact not only the middle section, but also the outer edges of the road, including the areas next to the ditches. This ensures optimal stability and drainage. According to Uwe Ode from the Hohenibra machinery base, this system enables simultaneous ripping, profiling, and compacting in a single pass, eliminating the need for material replacement. The ripper's placement on the middle blade keeps it in the operator's line of sight, improving precision and control. Adjustments in tilt, side shift, and extension can be made easily to match varying ground conditions. Overall, the HBM grader with Stehr attachments offers a cost-effective, fast, and sustainable solution for maintaining forest and rural roads. The parking lot maintenance process with seal coating begins by thoroughly cleaning the surface to remove dirt, oil, and debris using power blowers and sweepers. Any cracks are then filled with hot rubberized crack sealant to prevent water infiltration and further pavement damage. Once the area is fully prepared, workers apply a high-quality coal tar or asphalt emulsion sealer using spray or squeegee equipment. This protective layer restores the pavement's dark black appearance, shields it from sunlight, oil, and water, and extends its lifespan. After the coating is evenly spread, the surface is left to dry and cure properly before new parking stripes and directional markings are repainted. The result is a smooth, durable, and well-protected parking area. Recently, a fire completely destroyed the wood storage area of a hardware store in Barn. To quickly resume operations, a temporary site was created for storage and loading. Zwagstra Beton was tasked with installing more than 700 concrete slabs to form a solid, level surface. Thanks to their extensive inventory, in-house transport, and skilled installation team, all slabs were laid in a single day. This rapid deployment allowed the hardware store to reopen just a few days after the fire. The temporary site now serves as a safe and functional area for storing timber and handling deliveries. The use of precast concrete slabs provided an efficient and durable solution under pressing time constraints. Lindsay presents the Absorb M crash cushion system, designed to protect motorists from the ends of concrete barrier walls in construction zones and permanent installations. Fully tested to MASH TL2 and TL3 standards, the system uses water-filled plastic elements to safely absorb kinetic energy during collisions. The TL2 version has two elements spanning 14 feet 7.5 inches, while the TL3 uses three elements at just 21 feet, the shortest in its class. With interchangeable stackable elements, universal transitions, and forklift-accessible handling, the Absorb M ensures quick deployment and removal, minimal work zone exposure, and cost-efficient inventory management for contractors. The Maine Department of Transportation is using a movable barrier vehicle, commonly called the road zipper, to manage traffic on the state's most important bridge. This innovative system allows crews to shift lanes safely in just 15 to 20 minutes, a process that would take days with traditional equipment. By efficiently moving barriers, the project keeps traffic flowing during peak summer travel and holiday weekends. Although costly, the road zipper ensures safety, mobility, and smooth delivery of goods across the bridge while work is underway. The barrier transfer machine, commonly known as the road zipper, is an innovative traffic management technology designed to enhance road efficiency and safety in real time. This system employs mobile concrete barriers that can be repositioned to dynamically reconfigure traffic lanes according to demand. The road zipper is capable of lifting and transporting heavy, interlinked concrete barrier segments, allowing operators to swiftly adjust the number of lanes available for peak traffic flow or to create safe work zones in construction areas. In operation, the machine straddles the barrier line, lifting the connected concrete blocks using a specialized lifting mechanism. Once elevated, the road zipper moves laterally along the roadway, precisely shifting the barriers to a new position. This process enables the rapid addition of lanes in one direction during rush hours or the temporary narrowing of lanes to protect workers and drivers in construction zones. Unlike static traffic control methods, such as painted lane lines or plastic delineators, the use of substantial concrete barriers provides a physical separation that significantly reduces the risk of head-on collisions. The barriers themselves are designed to interlock, ensuring stability while being moved and maintaining their effectiveness as a safety barrier even after repositioning. The road zipper system operates continuously and efficiently, guided by trained operators who monitor traffic conditions and plan the timing of barrier transfers to minimize disruption. The machine is engineered to handle urban highways, bridges, and other high-traffic environments, where congestion during peak periods can lead to substantial delays and increased risk of accidents. By dynamically managing lane distribution, the road zipper helps to optimize traffic flow, reduce bottlenecks, and enhance overall road safety. One of the key advantages of this technology is its ability to provide instant flexibility in lane configurations. For example, during the morning rush, more lanes can be allocated to inbound traffic heading toward the city center, while in the evening, the configuration can be reversed to favor outbound commuters. In addition to peak hour lane management, the system is invaluable in work zones, where space constraints and the presence of construction equipment create hazards for both workers and motorists. The road zipper allows for the creation of safe buffers around work zones without permanently reducing the number of lanes available for regular traffic. Globally, the road zipper has been adopted in more than 25 countries, reflecting its effectiveness as a traffic management solution. Cities and highway authorities have integrated the system into busy corridors to address chronic congestion and enhance driver safety. Its deployment has demonstrated measurable improvements in traffic throughput and a reduction in collision risks, particularly in areas prone to head-on crashes. The system's reliability, combined with the physical protection provided by the concrete barriers, makes it a preferred choice for urban and interurban traffic management. In summary, the barrier transfer machine, or road zipper, represents a significant advancement in traffic engineering. By moving heavy, interconnected concrete barriers with precision and speed, it allows road managers to respond to changing traffic conditions in real time. Its ability to prevent collisions, protect work zones, and optimize lane use has made it an essential tool in modern road infrastructure, contributing to safer and more efficient transportation networks worldwide.